Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenter. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and our speaker today is Jim Bennett, who is a regional cloud advocate. I'll now turn it over to Jim.
Awesome. Thank you very much. Hello, good morning, good afternoon, good evening, wherever you are in the world. Welcome to today's session. Or in my case, the second session of today. If any of you joined me earlier, I was having a bit of fun with AI services and some wearable tech. So this is my second session of today. And today, with this session, I'm focusing on using a Docker container as a development environment with Visual Studio Code. That's what the focus is for this session. Now, this is a session where we can join in, we have a conversation. I've got a workshop to work through. But yeah, we can have a conversation here. I can take this kind of whatever direction you want. Happy to answer any questions. Happy to kind of support you, answer anything, any curiosities you've got, and just kind of redirect this a little bit as we go through things. And Ravi, good day to you. Great to have you with us. Welcome to the stream. Now, this particular thing I'm working through, you can follow along as well if you want to. So this stream is based off an existing workshop that we've put together. And if you go to aka.ms/devcontainers in VS Code, we'll just get the link will be in a chat in just a second. If you follow this link, you'll be able to not only follow along with this workshop, but because this workshop is free and open source, you can also take this and essentially do what you like with it. So what we've done at Microsoft is we've put together a workshop library of introductory workshops. This was built in collaboration with our student ambassador program. So these are students that we work with, we support them, and they work with their communities across their universities to help upskill folks in a wide range of technologies. So we built them some workshops that they can then take and run in their schools. So if you're a student on this call, welcome. Here are some workshops that you can run. But you can also be used by anybody for learning, or indeed, if you're the kind of person who wants to run a lunch and learn, or you want to get involved in your local meetup and you want some pre-built content for you, we got it here for you. We got all the things here for you to kind of help you run these kind of workshops yourself. So this particular workshop today is all focusing on dev containers, Visual Studio Code, but we've got stacks of workshops in here on AI machine learning, data, web and app development, with all the resources. So I'd know, pick this one here on static web apps, for example. Pick this one. It's a 20-minute workshop, and we've got everything you need here. So we've got a video walkthrough, so you can see how someone else has done this. So you can replicate this yourself. We've got all the stuff that you want to do, all the apps, a whole lot of bits and pieces, links to all the instructions and all the stuff you need to do. Some of our workshops even come with slide decks. So if you want to present, you want a slide deck. Let's see if this we've got a slide deck. Here we go. It's this one here. Build a website to showcase your resume. We've got the video on how to do it. We've got a link to a PowerPoint slide deck. Try it all out, what you need. So it's kind of all these workshops are kind of pre-built for you to kind of take and run. So I guess a question for the audience, really. Any folks on watching who would be interested in running a workshop? So anyone who gets involved with student learning communities, gets involved with meetups. If you are, if this kind of thing you're interested in, say so in the chat. I want to kind of hear whether this is of interest to you, whether it's something you would want to run. But certainly for today, we're going to be focusing just on one of the workshops, this dev containers one. So yeah, let me know if workshops kind of thing that you're interested in, and we can kind of dive into that some more if you want to. So let's actually start diving into this one. So aka.ms/devcontainers in VS Code. If you follow that link, it'll take you to this page in GitHub where you've got everything you need to work through this workshop. We cover the goals of the workshop, what you need installed, the slide deck. We've got video here. Actually, the video guides you through everything. We've got some pre-learning. If you don't know some of the concepts already, we've got pre-learning in here, prerequisites, what you're going to learn, and then all the instructions linking out to all the things you need to go through it. So this is what we're going to be working through today. Now, obviously, we're not just constrained to exactly what's written down here. We can play with other things. If you've got any questions, I'm here to help. So feel free to just ask away in the chat, and we can kind of get some good discussion going on a lot of the concepts that we're going to be learning today. So the whole point of this really is based around one of the frustrations that a lot of folks have when they start working with a new project. Now, anyone who's ever had to work with a new open source project or a new project in the workplace has probably come across the getting set up issue. Now, I'm an old hand in the tech world. I've been working professionally for 24, 25 years, a long time. And one of the continuous problems that's faced by new developers is getting set up to run a project. It's almost become a rite of passage. So you have a team, they're all developing away on their machines, and then a new person starts, and they're given an onboarding guide to get going with the new project. And this onboarding guide usually lists, here's the software you have to install, here's the tools, here's the IDE, here's the SDKs, this is the configuration, this is the registry settings or config settings or whatever else you need to get going. And in general, most of these onboarding documents are wrong. Usually heavily out of date. I hate to think how many times I've come to a new project and I've worked through the onboarding document and it just doesn't work. And then you've got the fun of going to the developers who've been on the project for longer and finding out what's the difference between their machine and yours. What do you have to configure? What do you have to tweak? Then you update the onboarding guide, and then other tools get installed, the guy gets out of date, and the next person starts, and it just gets this horrible mess. So what if there was a better way? What if you could literally one click and you are set up, ready to go? And not only just get your machine set up for one project, but have the ability to flip between projects and not care about what versions you've got installed, what libraries, what SDKs, what configuration. What if you could just grab a project and just have it work? Now, you could say, yes, virtual machines in the cloud are a great solution to this. You spin up a VM, you pay your VM costs, and everything all works. Not always great, costs a lot, doesn't work offline. What if you could just run it locally? What if you could have like a clean machine you install locally that you run with? And this is what Dev Containers solves. Dev Containers allows you to run your code in a clean environment that you configure it in code, check that configuration into your source code control, and everyone else can run your code the way it should be run with the dependencies that it's got. And this is what we're going to be looking at today. This is what we're diving into. So prerequisites for this workshop, if you want to follow along yourself, want to follow along with what I'm saying, a couple of things you need to be aware of. Some software development. This workshop does involve running Python, so you just need to have a rough idea of how to run some Python code, but all the steps are provided. Needs to know a little bit about Docker. So Docker is a containerization platform, and so you need to know a little bit about that because we use containers. But you know what? We can take a bit of time, actually. We can take a bit of time and kind of dive in to what is Docker if you haven't come across Docker before. Let's do that now. And so we even actually have built into our workshop some pre-learning. We've got a whole big thing all about containers and lots of stuff all about containers you can read. But essentially, containerization, containers, allow you to run a whole app, run something as if you're running on a completely clean operating system. So if you've ever used virtual machines before, a virtual machine it runs on your computer and you run it in something that emulates hardware. So as far as the virtual machine is concerned, it is running on bare hardware. It's got some processors, some memory that you've allocated to it via your virtual machine software, and your virtual machine kind of runs bare metal you install an operating system, and you run it. That's kind of a virtual machine. Containers are kind of a bit less than that. They're kind of the next level. Containers are kind of virtualized, not running on virtual hardware, but running on a virtual operating system. So when you run a container, that runs on the same hardware as like the rest of your computer, but as far as the container is concerned, it's running on a clean operating system. So you have a container that's got a clean operating system with nothing installed, and you can then customize what's installed inside that container. So every time this container runs, although it's running on your computer, it doesn't know about the software you've got installed, doesn't care about the configuration you've got. As far as it's concerned, it's running on basically inside a blank operating system kernel running on your computer. It's got full access to the hardware, so it can access your network, it can access all your memory, all your CPUs, but obviously you've got configuration to limit what it can and can't do. But essentially, it runs completely clean. It has nothing installed except what you tell it to be installed. Doesn't care the versions of software you've got on your local machine. It runs what it runs. And so this contains like completely clean environments. And what's great about a completely clean environment like this is once it's configured, everybody who runs the same container gets the same configuration. So if I have a container that's got Python 3.10 installed, I can give you the configuration file for that container. You run it and you get a container with Python 3.10 installed. And you can run that on your local machine with no Python or Python 3.8 or whatever. Doesn't matter inside your container. It's a clean machine with Python 3.10. So you kind of got this lovely ability to keep things clean. And so because of that, if you build all your code in a container, you don't have to worry about what's installed locally, only what's installed inside the container. Probably seems a bit weird, bit wacky, but as we kind of work through this, you'll see this in a bit more detail, and these concepts should make a bit of sense. So Docker is a tool for running these containers. So you'd have a container, virtualize your operating system, and Docker is a tool for running these containers. Docker it's free for learning, getting to know it. If you work in a large company, it's a paid for product, but for just learning it yourself, play with it at home, it's if you're a student, education use, it's completely free to use. Other prerequisite for this is a basic knowledge of Git, putting down a repo, just because we clone a repository for everything. So what are the learning objectives of today? So today we want to learn about the Visual Studio Code remote containers extension. We want to use that to connect with Docker container, launch this container access ports, tweak some settings, and add software to the container environment. All this probably sounds a bit confusing. Don't worry about this now, but this is what you get out of this by the end of it. And all these terms should make sense when we get to the end of this workshop. So that's where we are, kind of everything. So let's dive right in. And so kind of the aim behind using Visual Studio Code with a container is Visual Studio Code has an extension called Remote Containers. The Remote Containers extension allows you to develop inside a Docker container. Okay, so use the Remote Container extension to connect to a Docker container. We'll look at this a bit more in a little bit, but essentially we're using an extension in VS Code to run VS Code locally, but to develop inside a clean container. So let's actually do that. Let's just, let's get a project ready, and then let's look at installing this extension, kind of starting to think about how we can use VS Code inside this extension. So the first thing I want to do is I need to clone a sample repo. Got a sample repository here that has got a simple Python app. So I'm just going to grab this, and I'm just going to clone this. I've cloned it, and I'm going to open it in Visual Studio Code. So this is a simple Python app that I've got here. And if I try and run this, it's going to fail. I don't have stuff installed. But luckily, I have Python installed on my local machine. So I could run, in theory, I could configure this and run this locally. But, if I didn't have Python, I wouldn't be able to run this. So this is kind of the first barrier you would hit as a new developer. You get your brand new machine off the shelf, Linux machine, Mac, Windows machine, whatever, clone this repo, you've got to run it with Python. Do I have Python installed? Do I have the right Python installed? If I type Python on Windows, it puts this little shim in there that redirects me to the Microsoft store. Do I want that version of Python? So many kind of questions about, do I have the right Python on here just to run this code? So that's kind of things. How do we kind of solve that? It's, we don't want to have to go back to our onboarding document and write install Python. So many different versions. So that's kind of the first thing we hit by adding this. One kind of thinks about just running this on a clean machine. But this is the kind of problem we're going to solve. So step one is we need to install the extension. Now, Visual Studio Code, if you've not used this before, it is probably the world's #1 developer text editor. Stupendously powerful, great text editor, and it's got a whole load of extensions that adds more power. So it's all built on like an extension model where you can add loads of extensions to allow you to do things like use Python, use GitHub, connect to the cloud, develop IoT devices, whatever. So many different options you can get. And one of the extensions is this remote containers extension. And this is great. This is the one we're going to be using for this workshop. And so the remote containers extension lets you use a Docker container as a full-featured development environment. Whether you deploy to containers or not, containers make a great development environment because you can develop with a consistent, easily reproducible tool chain on the same operating system you deploy to. Kind of the most important part. With these containers, we can get this easily reproducible tool chain. So we can actually make sure that we're all using the same tools when we do it. Quickly swap between different separate development environments and safely make updates without worrying about impacting your local machine. Again, very important. What if I'm doing 3 different Node projects that all rely on different versions of Node? Imagine me to just swap between them and not care what version of Node is installed on my local machine, or even if I have got Node installed. When you've got so many different dependencies you have to manage using containers, a lot of these dependencies just go away. Make it easy for new team members, contributors to get up and running in a consistent development environment. That whole onboarding thing. I'm new to the team. How do I get started? Remote with containers gets you started. There's no onboarding doc. Or try new technologies or clone a copy of a code base that impacts your local setup. I want to try updating to a new version of Node. Okay, that's no problem. I install a new version, play with it. Doesn't work, just delete it and start again. I can get this whole thing self-contained. So this remote containers extension allows me to do all these things. And the idea of this is I can run a container and then Visual Studio Code connects to my container. So it runs all my development inside the container. And that we'll look at a bit more in just a second. So, now let's actually. So what have I done? I've cloned the repo, and I've installed the remote containers extension. So that's kind of got me going, ready to kind of get going with this containers. So how do I use this remote containers extension? How do I actually get going with it? What does it do? Well, as I said, Docker and VS Code make it possible to have projects contain their own pre-configured containerized environments using this extension. So what that means is I can configure a container, connect it from VS Code. Let's go straight to the picture. Best way to show it off is with this picture. So what you have is you have a container that you've set up using whatever you want inside the container, and that's what you code in. So you run Visual Studio Code on your local operating system. So I will run VS Code on my Mac, and I can configure the theme, any UI-based extensions in VS Code, and I have the source code on my Mac. So the idea is it's got VS Code running, I've got source code on my Mac, but then it connects to the container. So VS Code will spin up the container. Inside the container, it will run the VS Code server with any extensions I want to add that work against code. The Python extensions, JavaScript extensions, kind of whatever, will run inside my container. My container has its own file system, it's got its own terminal, it can run its own applications, it's got its own debugger, its own stuff installed in the container, and it accesses the same source code that's mounted from my local operating system. So I run it in my local OS, but really VS Code is running inside the container with all the stuff that happens on the container. And then when I run my container, I can expose ports on the container that I can access from my local operating system. We'll see that in a minute. But the idea is great. It means all the tools for development live inside the container and just inside the container. And that doesn't interact with anything else in my local operating system. And then VS Code just talks through to it. So it's kind of nice. If I can have a different version of Python in the container that I do in my local operating system. We'll see that in a second. Maurice F3 says, are there any machine RAM requirements for running a container? Yep, great question. Great question. So Docker itself can eat up some RAM. In fact, you know what? If I just go to my activity monitor, let's look at how much Docker is using. I mean, Docker's not using very much at the moment because I don't have a container running. But when I do run a container, we'll see this amount of memory Docker's using going up when I actually start doing it. And I mean, CPU, really not much more than what you'd be using anywhere if you're running stuff locally. Yeah, there's a little overhead for actually managing the container, but really, if a container's sitting there doing nothing, it's not really eating any of your CPU. We can have a come back to activity monitor when we start a container. We actually look at that impact directly. But really, it's a little bit of memory, not that much for not that much CPU. It all depends on what you're running inside your container. Containers are very lightweight in terms of their impact on memory and CPU and network and all that kind of stuff. But yeah, it's a great question. We'll actually come back to activity monitor when we've got one spinning up and we kind of see it all in action. Great question. So let's actually do it. Let's add a dev container, spin up the container, and then go back to Maurice's question and actually look at the impact that's got on my machine. So let's add a dev container to an existing project. And we can do all that using the containers extension that I've got installed. So got two machines going here to make sure I've got all the right instructions here. So I'm not filling up the screen all the time. So come here. In the remote containers extension, there's an option, add development container configuration file. So adding this will add a whole of configuration files to the project. Once those files are in place, VS Code knows to run this in a container. So add this. I'm going to use Python 3. So choose Python 3. Then choose my Python version for my container. I want 3.10. Bullseye. I'm running on Apple Silicon. So Bullseye. Don't want Node. And then I've got other features I can add, like the AWS CLI, Azure CLI, Docker and Docker support, .NET CLI, GitHub CLI, Ruby, Rust, PowerShell, Terraform, kubectl, Helm, Minikube. You know, I can add lots of stuff to it if I want to. And then this isn't the only thing I can add. So I can add stuff now as part of the kind of quick creation, but I can add more stuff in the future, which we'll look at in a minute. So do this, and this option pops up, reopen in container. So reopen this in the container. And then we'll kind of sit back. Things will happen. Give it a few seconds to rebuild because it just takes a bit of time to prep everything. Show my log. You see it's there. Getting the container started. Doing some stuff. Installing some stuff. Takes a bit of time the first time while the container is being built. Once the container is built, things get a lot quicker. One last reload. We're done. I'm now running inside a container. In fact, if you look down here, see it says dev container Python 3, editing on dev container Python 3. So my code is now sitting inside a container. And if I actually go back here to, so if I go back here and actually look at my activity monitor usage, you'll see it's using 5.24 gigs for QEMU system ARch64. So Maurice, going back to your question about containers. This is not sitting here in physical memory. This is going to be heavily compressed memory. But this is kind of the emulator that runs for Docker. So Docker itself is not using up 5 gigs of RAM. It's just kind of allocated that to kind of do stuff. And most of that's compressed. But that's kind of the memory hit that you've got because it's sitting there just as a container, not doing much. CPU here, it's using 17% of my 21% of CPU, out of however many million percent I've got because I've got 8 cores in this thing. So, it's not using that much CPU, does take a big memory allocation. So if you're doing a lot of stuff with containers, you want a machine with a lot of RAM. But I mean, I'm on a base 8 gig MacBook Pro and it's running and it's cool. No issues at all. But this container, this is running. So what this is running in is essentially a brand new computer as far as it's concerned. So all the stuff about this is defined inside a .dev container folder. The existence of this .dev container folder tells VS Code to run everything in a container. Once you have this in place, VS Code wants to run inside a container. In fact, you know what? If I quit VS Code and go here and relaunch VS Code, what it will ask me in a second, do you want to open this in a container? Reopen in container. So just by having that .dev container folder in place means it wants to run it in a container. Now in this .dev container, I have two files. I have the dev container.json and Dockerfile. The Dockerfile defines the rules or defines the container configuration of the actual container that's built and launched. And so if you've done Docker before, probably recognize this kind of format, but essentially it starts with a from line that says what is the base container. So this is a MCR Microsoft.com VS Code dev containers Python, and the variant is 310 bullseye. So this is saying run on an ARM64, an Apple Silicon version of Debian Linux version, Debian Linux bullseye. Bullseye is the latest version of Debian with Python 3.10 installed in the container. So that's the basic images. So although I'm running on a Mac, essentially I'm running Linux. I'm running a Linux container on here. And there's a couple of extra lines to install Node, but I've got my version as none, so Node is not installed. I'm just literally running a Debian container using Python 3.10. And I can prove this. If I go here and type in Python ---- version, I'm running Python 3.10.4. That is the version of Python inside my container. I do the same thing on my local machine. 3.10.2. So on my Mac, I've got one version of Python. On here, in my container, I've got a different version of Python. It's completely isolated. This is my path /workspaces /mslearn Python products. This is a mounted path. So this mounts my folder, my mslearn Python products folder on my local machine to the container. If I actually go back to this folder on my local machine, ls-a, you see I've got my .dev container, the newly created dev container folder. If I do a GitHub status, git status, even, it's added the .dev container. So locally, I see the files being changed, but that's all I see. I don't see everything else. If I actually change to this workspace mslearn Python products directory, no such file or directory. So it's mounted completely differently. And other stuff, I've got stuff locally, don't have that stuff on the container. If I do node ---- version, got node 16.14.2, I go into my container, do exactly the same thing, node command not found. So it's kind of this clean, isolated container that's configured just what I need. And this means if you were to take this, if you were to clone this, if I check this in, you clone this repo, you run this, click open in container, you would also get Debian running with Python 3.10 on there. Which is pretty cool. Now, you don't it says use Bullseye for ARM64 Apple Silicon, but Bullseye will also run on other platforms. So you run this on Intel Macs or Linux on Intel or Windows on Intel. 3.10 Bullseye would work. You just get the Intel version rather than the ARM version. The other file we got here, dev container.json. This file here describes how the dev container should be built by VS Code. So it gives it a name, Python 3, just this name down here. You'd probably want to call this whatever's your project, maybe with a version as well, kind of whatever is a sensible name for your project. It says build it using this Dockerfile, this one here. The top got one level for my source code, and this is kind of the arguments. So Dockerfile has got some arguments in here, but you can pass in new versions of arguments if you want to. So we reconfigure versions inside the Docker dev container.json if I want to configure versions. So the container lives inside the dev container folder. What's the size of the folder? No, no, not quite. The dev container folder contains text files that describe the container. So this Docker file here just describes the container. It doesn't actually contain the version of Linux. There's no actual bit large image. It's not like a virtual machine image that lives in this container. This container is just text, 21 lines of text. If I check this into source code control, it will just check in this Docker file and this dev container.json. It just checks those in locally. Doesn't check the images in. In terms of the images, they are all managed by Docker. If I launch up Docker Desktop, bring up the dashboard for Docker Desktop, this is my container. So inside Docker, it created this container, and this sits there and kind of lives, and it's called VSC, MSLM, Python, procs, blah, blah, also known as quirky toolsig, because silly names. If I look at the stats, this is currently using 331 megabytes of RAM, 6% CPU. So again, Maurice, going back to your question of the usage of this, I can monitor the CPU usage, not very much at all. Don't know how to see how big the container is. Let me see. Oh, here we go. So images, here we go. So this takes up 1.12 gigs locally. So the container itself is running locally. It's kind of inside Docker. Where it lives where actually the image lives on my machine, I don't know. I'm assuming there's some kind of Docker folder somewhere where all these containers live. So this lives on my machine, doesn't live up in source code control. When I commit the changes to source code control, if I do there, ls-rt, I'm committing 1.3 kilobytes the Docker file and 1.9 kilobytes the dev container.json. So that's all it uses up in source code control. This size is just used locally when the container is created. So when I run, I've got my container created. If I rebuild my container with small changes, it will just tweak what I've got here. If you ran this for the first time, it would need to allocate 1.12 gigabytes in size. And it's kind of smart enough. They kind of grow as needed as you add more files. They kind of grow there. So hopefully that answers your question. Yeah, in terms of in source code control, it's tiny, absolutely tiny. So that's kind of the details of what Dockerfile to use. Then we have the Visual Studio Code settings. So this dev container.json is designed for Visual Studio Code. So we have things like our Python interpreter path, whether you want linting enabled with PyLint, where autopep8, black, yapf, bandit, flake8, all these kind of things, all these different installs. So if I wanted to add more Visual Studio Code settings, I could add those in here. And they would be applied to the VS Code running inside the container. So not VS Code running locally. If I spin up VS Code locally, it doesn't make these settings. These are just these are applied to the VS Code that runs inside the container. Same with extensions. I can say what VS Code extensions I want installed inside VS Code. And this is saying I want Python and Pylance. Let's go to my extensions here. Pylance. I think it's currently installing an update. But that's installed. No reload required. So it's just push installed an update. Answer your question. Awesome. Awesome, Maurice. Thank you. So it's just literally an update to the extension came out as I was showing it. But yeah, so this shows that I've got Pylance installed. Oh, if I could spell. Pylance, it's installed. And that gets configured here. So I can add anything to this as well. If I wanted more extensions, I could do it here. And then I can add a load of other stuff, post-create options, kind of configure my container. But what this happens now is if I check this code in, if you were to pull this code, launch it in Visual Studio Code, you would get this same container running locally with all your stuff. Which is pretty cool. It's pretty cool. If I wanted to run this, if I do Python app.py, it doesn't work because I haven't installed my packages. But if I then do install my Python packages, chug, then now when I run this, it'll run. It's now running inside my container. So that's now started up. Give this a second. And it tells me I've got forwarded ports. And see this ports tab here with a 1. So this is saying port 5000 in my container is forwarded on to port 5000 on my local host. So from my Mac, here I am on my Mac. If I go to 127.0.0.1.5000, this is accessing the Python web app that's running inside the container. So here I am. If I actually go back to it, go back to my terminal, look, we did a get on root. Refresh that, we did another get. So the port has been forwarded. The application runs in the container. Port 5000 is exposed on the container and maps to port 5000 inside the container. So when this runs, where's my code? When I run this defaults to port 5000. It's kind of what Flask does. And then VS Code automatically picks up that port 5000 has been exposed and exposes that to the outside world, just port 5000. Again, if I just bring up another, bring up another terminal, and if I do ps-ef pipe grep -i Python, that shows all the running Python processes, we have got user local bin Python, workspaces, mslearn, Python products, app.py. So this is my Python up running in my container. But if I take the same command and I run this on my Mac, I do not have that running. So as far as my Mac is concerned, no, there's no Python up running because it runs inside my container, which is very, very cool. Now these containers, I've run this command to install my Python packages, all because I've installed it in my container. That does not persist. So it's in my container. And if I were to actually rebuild my container, which kind of go back, rebuild the container, kind of delete all the stuff, rebuild it based off the Docker images. If I rebuild it, try and run it, it fails because the pip packages were installed in one image of the container. When I rebuilt it, they get lost. So this is kind of really good because this would then encourage me, if I wanted to install something, if I install it locally, rebuild my container, it goes away. And so if I install it by adding it to my dev container files, then that reminds me I've got to put it in there ready for the next person to pick it up so they don't hit the same problem. And we'll look at that a bit more in a few seconds. That's it. So we've added the container to the project. And we've added the container, looked at the configuration files. So let's customize some settings. Let's actually make some more settings in our container to customize it so we can then use this, do more things that then get shared with whoever else uses our container. So we've got the dev container. Yeah, we looked at it. We talked through the Dockerfile. We talked through that. We talked through the settings that are there. And there's other things we can add to it. We'll look at those in more detail. But let's do some customizing. Let's actually do some project settings. So what I want to do is I want to do this one here. What I want to do is, first of all, I want to show you part of the project. This is a Flask app. If you've not come across Flask before, it's a Python framework for running web apps. Okay. And what you can do inside your web app, you can have templates. Here's an HTML template, and we've got this kind of weird syntax here where for products in products, do something. Notice there's no syntax highlighting on here at all. But the idea of this is Flask, you can say, here are the products, render the template, and that will then go through this HTML and repeat it for every single item in the products list, filling out the details. This is kind of spits it out. This is what gives us this. Each one of those is a product object that's passed through to the kind of the rendering code to take that. We don't have any syntax highlighting here. Now there is an extension called Ginger from here I can use to do syntax highlighting. So if I install this and then go back to my template, I get syntax highlighting. Problem is, if I rebuild my container, or or you take the container. Oh no, it's installed in VS Code. So, but it's installed in VS Code. If I close VS Code, relaunch VS Code, let's actually do that. Let's see if it's going to play nice. Give it a second. Oh, wrong folder. Wrong folder. So in theory, if I reopen this in the container, oh no, okay. So I think it's still got the extension loaded because I'm running everything locally. But if you were to take this and run it, you wouldn't get the syntax highlighting because you don't have the extension installed. So what I can do, I can actually add this extension to the extensions list here. So if someone else to take this and run it, they would get the extension installed automatically. So go here, search for Ginger. And then this is the identifier, Holroyd.ginger. Copy that. And I can just add that in here. Rebuild the container. And that way, going forward, that one is automatically installed. I can do this kind of any extension I think is necessary. So there we go. It's pretty cool. Oh, reload the window, whatever. So it's pretty cool. If there's extensions that are useful, I can put those in there. If you're building a web app and you want to add some JavaScript extensions, you can do that. If you're building your Python, you want to add Pylance. It's obviously already here in this example here. If you're then deploying this to Azure App Service, you know, I could then go to Azure App Service and then just add this if I wanted to. Yeah, I can kind of add a lot of extensions to it. So I can add the extensions that are relevant to the developer. It's pretty cool. Another thing I might want to think about adding is my pip install. Because if I come into my container, actually run this, it just doesn't run out off the bat. What I could do is I could actually automatically install the requirements. So if I just add this entry here, this is in my dev.container.json. It says post create, run this to pip install my packages. Now, we could talk about, yes, you should use virtual environments, but I'm inside a container. It's kind of like the ultimate virtual environment. So I could just install these requirements. And so if I do that, if I make that change, rebuild the container, what it would do is part of the container startup, it'll install those packages. There it goes. Install, 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 install. Done. So now if I run this, it's up. So yes, reload because Pylance. Yeah. So what this means now is if I check this code in, you grab this container and run it, you better literally install it, type in python app.py, and it'll just work. Because inside the container, I'm installing all the packages, which is pretty cool stuff. You know, none of this setup, none of this, oh, well, here's the install guide to get this project working. You have to install Python 3. You have to pip install the packages. Like, oh, well, you didn't do a virtual environment. So you need to do a virtual environment. You got this version installed in your virtual environment. This one not in your virtual environment. Activate, yeah, blah, 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 blah. None of that. It's just, it's in the container. It just works. It's really, really nice. And to say, anyone can grab this, run it, whether you're running it on Windows, Linux, Mac, you just grab this when it just run. It's great. Absolutely great. Again, just going back to Maurice's original question about performance and all that. So this container is still sitting at 1.12 gigs. Let's see if I refresh it. Yeah, 1.12 gigs. If I go, oh, it's already running. If I go inspect, here's what's got run on there. Here's all the stuff that's happened to get it going. Yeah, 398.5 meg of RAM, few percent CPU usage. So it's running, it's working, it's not using that much CPU usage, not using that much memory. Pretty sweet, pretty sweet. So we've done a bit of customization. We've got it so that adds the Ginger extension and then installs the pip packages. So that's what we've done. What if you want to, say, add more software? What if you want to actually add another tool to the tool chain? Again, we can do that. We can just put it in our Dockerfile, and it will just be applied to everybody who uses this container. So say, for example, we want to install Node. You want to install Node.js inside this container. I can just install it using the terminal. I could go into my terminal here and then go, apt-get install Node.js, whatever. But the problem is, if I do that, that exists inside this container. When I spin up this container, it'll exist. When I rebuild the container, it's gone. When I give you my .dev container folder, it is gone. So I can then kind of add new things. So if I add anything myself, it gets lost. So I need to add it into the Dockerfile. Josefa says, is this limited to Linux dev environments only? Now, I've not actually tried with a Windows container, I must admit. I know Docker supports Windows containers. In general, most folks use Docker containers on Linux. That's kind of the norm. And running a Linux Docker container on Mac, Windows, and Linux kind of just works. But yeah, should work with a Windows container. I've just never actually tried it. Because obviously Windows is there's a bit more to Windows than just the raw kernel. So it should work. I've never actually tried. Maybe some homework for you is to give it a go and find out. You know what? Yes, code, remote container, Windows container. Let's see if anyone's actually done anything. So I'm going to look at the docs. Okay, so only supports Linux containers. There we go. So you can run on Windows, but you need WSL2 or Mac or Linux. Yeah. So go back to Maurice's question. 1 GB RAM is required. At least 2 gig and a 2-core CPU is recommended. So don't need that much power. So yeah, but it only works on Linux containers. So there you go. Can't use it with Windows containers. Could be an interesting experiment to see how well it would work, but this is designed, x86, x64, and ARM v7, v8 on Debian, Ubuntu, CentOS, Red Hat Enterprise Linux, and then Alpine on x86, x64. So no. So yes, to answer your question, then yes, it is limited to Linux environments only. Great question. I hadn't really thought about that. I'd never really touched Windows containers. I'm on a Mac anyway, so I can't. But no, great question. So if we want to install software, we need to do it from the Dockerfile. So in the Dockerfile, we actually put the instructions to what software we want to install. So let's add Node, for example. Let's add Node to this. So if I go to my Dockerfile here, I've got everything installed. Let's add Node. So every time we type run in a Dockerfile, that kind of adds what's called a layer into Dockerfile. So you have, this is one layer, this would be another layer if it did anything. This was another layer. And then each layer is kind of stacked on top of each other. And what's cool about this is if I change a layer down here, when it rebuilds the container, it just rebuilds this layer, not the other layers on top. So I don't have to go I don't have to go back and it can take a long time to maybe pull the container and build the first version. But if I add just something further down here, all this stuff going up doesn't get changed, just the stuff going down, which is really, really nice. So I add this run on the end, don't have to rebuild much of my container. I'm going to just run apt-get updates. Need to do that. Put a slash on here so I can go on to the next line. This allows me to put entries in my Dockerfile that split over multiple lines. And then I need to install curl, -y, curl, and CA certificates. Now, I need to install curl because I'm using curl in a second to pull something down. But this -y means yes. Yes to the question, are you sure you want to install it? If you haven't run apt-get before, when you run it, it would usually say to you, installing this package will take this amount of space. Do you want to do it? Yes or no? Now, because this is a Docker container being built, there is no interactive environment here. So that if it sits there waiting for an answer, it'll just bomb out. So, no, not get an answer, I'm going to bomb out. So I say -y to say, yes, I do want to install it. Don't bother me. It's not interactive. Just, yes, install it. You want to make sure that anything you install doesn't have the ability to ask you questions because you cannot answer them in the container. Once I've done that, I'm going to just curl the install script for Node, https //dev.nodesource.com/setup 14.x, that's the latest version 14, and pipe that to bash. So that just runs a script to set up Node, and then I'll just actually do the install. Install Node.js in the Node source. And that's it. So now if I do this, rebuild my container, this will go off. If I show the log, you'll see this is now doing zip through quickly, building everything else, and now it's actually installing the new bits and pieces. Chug, chug, chug. Spin it up. And that's it. Now my container's built, and it's going through, doing the Flask things. Installing stuff. Yep, pile answers installed. Read out the window. Now I'm done. And if I now do node -- version here, it's now installed 14.19.1 of Node. I'll do npm -- version 6.14.16 of npm. So that's now installed. And if anybody then gets this and then builds their own container, they will get the same thing. They will automatically have it installed. And again, if I do the same thing locally, I go here and go node -- version 16.14.2, npm -- version 8.50. So 16.14.2, 8.50, 14.19.1, 6.14.16. So completely different versions, completely isolated. This knows nothing about the node I've got locally. Locally knows nothing about the node I've got inside the container. So I've kind of got this lovely environment now. So literally I could check this code in. I'd be checking in just these two files. And then anybody who grabs this opens it up in VS Code. It'll ask to open up the container. You say yes. It'll build you a brand new container. It'll install Node. Python's already installed because it's part of the container. It'll install these extensions, install the pip packages, and bosh, you've got a fully working environment. Now, obviously, this is a very, very simplified example. In the real world, you would have a lot more things. You'd be installing Node packages. You might be doing some kind of other configuration. You might be installing, the npm installing all manner of yarns and, whatever other tools you might want to have. There's a lot of stuff you want to configure. But the fact you always configure it inside this Dockerfile and dev.container.json means you've got this kind of configuration as code type idea. Your onboarding document is literally these two files. A new person starts, it's just clone the repo. They get the repo, it just works. If you're building an open source project, you want people to contribute. You don't want to have, here's all the steps you have to do to configure your open source project to actually start fixing issues or making code changes. No, here's the dev container, just go. So it's kind of really, really good. There's a number of different repos that kind of looking at this kind of approach. And I thought Laravel actually had this. Okay. There's a few repos that actually look at this idea of, I thought Laravel did. Oh, well. There's a number of repos kind of look at this idea of putting a dev container in there. So if a new person wants to contribute towards an open source project, they will literally clone the repo, open it in VS Code, open a container, you're all set up, ready to go. It's absolutely fantastic. It's great for onboarding people, great for working on new projects. Awesome, that's what we did. We added it, rebuild the container. So that's it. We are done. What have we done? So we've learned a little bit about containers. We've learned how you can use them to develop an environment. We installed the remote containers extension and used that to actually get our container configured. And then we played the configuration files, explored those, kind of got used to it, and then customized our container. And we kind of got to this point where now we can literally clone this repo with this code, launch it VS Code, run it up, run our app, forward the port so we can access it from outside the container, and we've got just a completely self-contained development environment. So that's it. That is how you get going with dev containers and Visual Studio Code. Monty Evans says, great stuff. Thanks. Thank you very much. Hope this was useful. So yeah, if you're doing this with yourself, you don't think with containers, reach out, let me know kind of cool things you've been doing. Hope this is useful. And as I said, all this stuff, this workshop I gave today, all the rest of our Microsoft workshops, they're free for you to use. So if you want to come and run this yourself at your meetup group or lunch and learn at your workplace or your University Computer Science Society, kind of wherever, this is here for you to use. Dean Weiss says, thank you. Yep, thank you very much for joining. Maurice, thanks for the walkthrough. Again, thank you very much for joining. Some great questions, Maurice. Hope I managed to answer those for you successfully. But otherwise, yeah, thank you very much, everyone.
Thank you, Jim, and thank you, everyone, for joining. Before we go, if you have a moment to take our survey, we'd love to hear what you have to say. We'd love to hear if there's other content you would like to hear about, anything. We'd just love all the feedback. So for this specific event, it's 15830. Love to hear from you. Until next time. Thank you, everyone.
Thanks, everyone.
Bye.
Bye.